In this video lesson, we are going to be classifying and naming all of our different kinds of polynomials based on the number of terms that they have, as well as based on the degree. So first thing that we want to go ahead and do is take a look and identify how many terms there are in each one of these, and then determine the degree. Now remember, my terms are separated by either an addition or subtraction sign. So if I take a look at the first one, it's 3x plus 2. So I have a 3x as one term, and then that 2 as a second term. So there are two terms in this polynomial. If I take a look at the next one, it's 9x squared minus 5x plus 1. Well, 9x squared is a term. That negative 5x is a term, and so is that 1. So there are 3 terms in this polynomial. The next one is just 15x to the third. So that right there is just one term. The following one, we have 4x squared minus 3x to the third plus 2. So we have 1, 2, 3 terms. And that last one right there, I have a negative 1 plus 4x minus x to the third plus x to the fourth. So I have 1, 2, 3, 4 terms. Next thing we want to identify is the degree. The degree is the highest exponent in the polynomial. It is the highest exponent in the polynomial. So if I take a look at that first one, the highest exponent goes with this 3x. Even though I don't see it, there is an implied degree of 1 or exponent of 1 here. The next one, the highest exponent or the highest degree, is that 9x squared. So this has a degree of 2 because 2 is the exponent. Following one is 15x to the third. That one has an exponent of 3. Now the next one is out of order. It is not 4x squared that is the highest degree. It is a negative 3x to the third. So this one has the highest degree of 3. The following one is also out of order. We have to find the highest degree. And that highest degree is at x to the fourth. So this has a degree of 4. Now based on the number of terms and the degree, we actually give it different names. So for example, the degree for anyone that has a degree of 1 is called a linear. A degree of 2 is called a quadratic. A degree of 3 is a cubic, and a degree of 4 is quartic. Number of terms also has different names to it. 1 term is a monomial, 2 terms is a binomial, 3 terms is a trinomial, and anything bigger would be considered a polynomial. So if we take a look at the first one, it has a degree of 1, and it has 2 terms. So we would call this a linear binomial. The next one has a degree of 2 and 3 terms. So we would call this a quadratic trinomial. Next one has a degree of 3 and it is 1 term. So we would call this a cubic monomial. Next one has a degree of 3 and 3 terms. We would call this a cubic trinomial. And the following has a degree of 4 and 4 terms. So we would call this a quartic polynomial. Now that we have practiced classifying them, we are going to go ahead and we are going to practice adding and subtracting. So if we take a look at the first example right here, we have the quadratic trinomial 3x squared plus x plus 2 added to the quadratic trinomial 2x squared minus 2x plus 1. When we are adding our polynomials, we combine like terms. So anything that has an exponent of 2 will be combined with an exponent of 2. Anything that has an exponent of 1, anything with no exponents, we end up adding like terms. So if we look here, this 3x squared and this 2x squared are like terms. So we would combine them. So 3x squared plus 2x squared would give us 5x squared. Another thing that is a like term is this x and this negative 2x. Well, x and negative 2x combine to being a negative 1x. And then the last like terms that we have on this problem is a 2 and a 1. Whenever I combine a 2 and a 1, I get a positive 3. So we end up getting the answer of 5x squared minus 1x, or just minus x, plus 3. Let's go ahead and name this. This has a degree of 2, and it has 3 terms to it, so we would call this a quadratic trinomial. Take a look at another example. Now this one right here is subtracting. This one right here is subtracting. Anytime we see that we are subtracting our polynomials, what you have to do is you have to distribute that negative sign to everything inside the parentheses before you can do anything else. So you want to distribute that negative sign to everything. That means that this becomes a negative 5x squared minus 3x minus 2. You have to distribute it across that parentheses in order for you to actually see that you are subtracting the entire polynomial. So now we're going to go ahead and combine our like terms. So I can see that 2x squared and this now negative 5x squared are like terms, and that would give us a negative 3x squared. We should also see that this x and this now negative 3x are like terms. So then that would give us a negative 2x. And we should also see that this negative 3 and this negative 2 are like terms. And that would end up giving us a negative 5. So let's go ahead and let's name this polynomial that we see. So if we look at this polynomial that we see, it has a degree of 2 and it has 3 terms. So we would call this also a quadratic trinomial. Let's keep practicing. So the next one, again, we are adding, so we combine our like terms. Now if we see, there is no like term to this 2x squared. So it just comes out front. But we do have like terms of this 3x and this x. Those will combine to being a 4x. We combine our like terms to our next ones. That is an 8 and a 4. Those combine to being a 12. So let's go ahead and name it. This has a degree of 2. It has 3 terms to it. So we would call this a quadratic trinomial. Let's look at the next one. Again, this has a subtraction sign. So before we can even do anything, we need to make sure that we are distributing that negative to everything inside that polynomial. So that way we're not just saying that we're doing it to one of them. We're actually subtracting the entire polynomial. So if we distribute that subtraction sign, we get a negative 5x squared minus 2x and then minus 3. Now we can combine our like terms. This 3x squared and this now negative 5x squared combine to being a negative 2x squared. This 2x combines with this negative 2x, but a positive 2x and a negative 2x end up canceling out or reducing out. So that means that I don't write it in my answer. If they end up canceling out, they are just not written in my answer. Then if I look at my other like terms, I have an 8 and a negative 3. An 8 and a negative 3 gives me a positive 5. So if we look at our ending answer here, we get a negative 2x squared plus 5. This has a degree of 2, and it has 2 terms. So we would call this a quadratic binomial. Let's look at a couple of more. So if we take a look at this one right here, we're going to combine our like terms by adding. There is no like term to this 3x to the third, so we just write it out in front. But we should see that this 2x squared and this 3x squared are like terms, giving me a positive 5x squared. We should also see that this negative x and this 2x are like terms, and they will combine to being a positive 1x, or just plain old x. We should also see that this negative 3 does not have anything to combine with, so it's just minus 3. Now let's go ahead and name this. This has a degree of 3, and it has 4 terms to it, so we would call this a cubic polynomial. Take a look at number 6. If we look at number 6, we should notice that we are subtracting our polynomials. So before we can do anything, we need to distribute that subtraction sign to the entire polynomial. So that way I am subtracting the entire polynomial, not just part of it. So if I subtract it, I get a negative 3x squared minus 2x, and then this now becomes a plus 2 because a negative and a negative 2 make a positive. So remember, 2 negatives create a positive. Now we combine our like terms. Well, this 3x squared and this negative 3x squared ends up canceling out or reduces out. If they cancel or reduce out, we do not write them in our answer. We should also see that this 2x and this negative 2x also cancel. If they also cancel, again, we do not write them in our answer. So this one right here, we see that we have a negative 1 and a 2. If we combine a negative 1 and a 2, we end up getting an answer of 1. Well, if we look at this answer of just plain old 1, there's no letters with it. That means that this one right here is called a constant. A constant is just a number. A constant is just a number. Now, since there's just one number here, it is going to be considered a constant monomial. I want you to go ahead and put a star next to this because this one is special. You don't see this all the time, but if you do see this, you have to understand that since there is no variable with it, it's considered a constant, and since there's only one term, it is a monomial. Let's look at two more together, and then I'm going to have you guys practice a little bit on your own. So if I look at number 7, again, I am adding them, so I'm going to combine my like terms. So I have this 2x to the 4th and this 3x to the 4th. If I combine those, they end up giving me 5x to the 4th. I also see that I have a 3x and a negative 3x. Well, those will cancel. So I do not write them in my answer. And then we see that we have a negative 2 and a positive 1. Well, that negative 2 and that positive 1 gives me a negative 1. So let's look at our answer that we have. We have 5x to the 4th minus 1. Because it has a degree of 4 and it has two terms, we will call this a quartic binomial. And then let's take a look at number 8. Again, we should see the fact that there is a subtraction sign in between that, which means you need to distribute that subtraction sign to the entire polynomial. So that way we're not just subtracting one piece, we're subtracting the entire polynomial. So if we distribute that, it will give us a negative 8x squared minus 3x plus 15. Now let's combine our like terms. 10x squared and a negative 8x squared will combine together to being a 2x squared. Next like terms are x and negative 3x. Those will combine to being a negative 2x. And then my last like terms here is that negative 15 and now a positive 15. Well, a negative 15 and a positive 15 will cancel. So I will not write them in my answer. So if we retake a look at my answer, I get 2x squared minus 2x. Because this has a degree of 2 and it has two terms to it, we would consider this to be a quadratic binomial. So we have just done 8 problems together. I want you to go ahead and take a second and try 8 on your own. So go ahead and try the 9 through 20 on your own, please. Go ahead and try 9 through 20 on your own. Now that you guys have been practicing adding, subtracting, and doing the labeling of the terms and degrees by giving them their specific names, let's go ahead and let's create our own examples. So if we take a look at number 21, it says, give an example of a quadratic binomial. A quadratic binomial. Now remember, because it says quadratic, that means that your exponent or your degree has to be a 2. Has to be a 2. Now because it's a binomial, that means you should have 2 terms. You should have 2 terms. So we could make this anything that we wanted as long as it has an exponent of 2 and it has 2 terms. So an example of a quadratic binomial could be x squared plus 1. This would be an example because it has a degree of 2 and it has 2 terms. It has a degree of 2 and it has 2 terms. Why don't you try writing your own? Now let's take a look at number 22. It says, give an example of a cubic monomial. A cubic means that it has to have a degree or an exponent of 3. A monomial means that it has to have one term. So we could make this anything that we wanted as long as it has a degree of 3 and it has one term. So an example of a cubic monomial could be a negative 2x to the third. This is a cubic monomial because it has a degree of 3 and it's only one term. Why don't you try making your own? Let's look at a couple more. Number 23 says, give an example of a linear binomial. Linear meaning that it has to have a degree or an exponent of 1. And a binomial meaning it should have 2 terms. It should have 2 terms. So we could make it anything that we wanted as long as it has a degree of 1 and 2 terms. So an example of a linear binomial could be 16 minus 3x. This is a linear binomial because it has a degree of 1 and it has 2 terms. Why don't you try creating your own? And at number 24, it says, give an example of 2 binomials whose sum is a quadratic monomial. 2 binomials whose sum is a quadratic monomial. Now, because it's telling me to have 2 binomials that creates a monomial, that means that one of the terms must cancel. That means one of the terms must cancel. And the other term has to be a quadratic. The other term has to be a quadratic. And because I'm talking about sum, I am talking about the addition. I am talking about the addition of them. So an example of 2 binomials whose sum is a quadratic monomial could be something like x squared plus 3 plus x squared minus 3. Now this is why. Let's check it. If we combine our like terms, we should see that x squared and x squared will combine to being 2x squared. But if we take a look here, 3 and negative 3 will end up canceling. So that means that I wouldn't write them in my answer. So the only answer that I would have for this one right here would be 2x squared. Well, 2x squared is a quadratic monomial, so this right here is a great example of 2 binomials whose sum is a quadratic monomial. We are going to end today's lesson with an error analysis. So we need to look right here at this situation. It says 3 students were asked to simplify the polynomials of 3x squared minus 5x plus 4 plus x squared plus 3x minus 5. We need to figure out whose answer is correct and what mistake did the other students make. Well, first thing that I want to do is I want to go ahead and do my own work down here underneath their work so that way I can figure out who's correct. And then I can use that as a starting off point to identify who made a mistake and what their mistake was. So if we go ahead and rewrite this down underneath, we will have parentheses 3x squared minus 5x plus 4, and then plus parentheses x squared plus 3x minus 5. Now we want to combine like terms. So we should see that 3x squared and x squared combine to being 4x squared. We should also see that negative 5x and 3x would give me a negative 2x. And then the last thing we should see is that this 4 and this negative 5 will give me a negative 1. So let's go ahead and find out who did it correct. Who got the answer of 4x squared minus 2x plus 1? And the person who got it correct was Alicia. Alicia got the same answer as us. So that means that she is the one who did it correct. Now let's take a look at the other two and see what they did wrong. So let's take a look at Ramilla. So if I take a look at Ramilla, I see that she got the 4x squared right. So I know that she did that part right. But how in the world did she get an 8x? And how in the world did she get a 9? Well, she got the 8x and the 9 because she did not look at the actual signs. All she did was she just added the numbers without looking at the signs. So she added the numbers without looking at the signs. She didn't see the fact that 5x was a negative 5. She did not see that negative 5 was a negative 5. She just saw the fact that they were both positives, and so she added them together. That's how she got the 8x and the 9. So she messed up by getting that 8x, and she messed up by getting that 9 because all she did was just add the numbers without looking at those negative signs. So now let's look at Kaylin. Well, Kaylin, at first glance, looks like she might have done it correct. Because see how she got the 4, the negative 2, and the negative 1? That's exactly the same as what we got. However, she got an exponent of 4 here, and she got an exponent of 2 here, which is not correct. So what she did wrong was she added the exponents. She added the degrees together. And you cannot add degrees together. If it is a like term, the actual variable and the degree of the variable does not change. Only the coefficient does, or only the number in front does. But what she did on accident was she accidentally added those degrees together when you really should not.